Hey, mathletes, what we're going to take a look at in this video is something known as similar objects. Now, what does it mean to be similar? Well, to be similar means that two objects are essentially replicas of each other, but one is smaller or larger than the other. But all the dimensions have to be changed by the same amount. So what I want you to think is all dimensions are changed by the same amount. Now, the good news is here, it's actually really easy to tell if two objects are similar or not. So for instance, let's consider these two cylinders. And I want to say, okay, are these two objects similar? So what I'm going to do is I'm going to compare the heights to each other, and then I'm going to compare the radii to each other. And I'm going to find the scale factor. So remember, to find my scale factor, I'm going to take the new, or the diagram, and I'm going to divide it by the old measurement, or the actual measurement. So for the height, I get a k value of 2. Now I'm going to do the same thing for the radius. So I'll compare these two things. So I take the new and divide it by the old, and guess what I get? 2. Since both of these scale factors are the same, therefore these two shapes are similar, right? Because they were both dimensions were increased by the same amount. All right, not so bad, right? Kind of an easy kind of idea to tackle. Okay, let's try another one. So for the cube here, what I want to say, well, it's not a cube. It's a rectangular prism, if I want to be precise, but are these things similar? So what we're going to do, friends, is we're going to check 3 different dimensions. So first I'll check the length. Okay, so it's not enough to just check 1 or 2. I got to check all of them. So I'm going to check my length. I'm going to communicate that I'm checking the length. So I'm going to go new divided by old. When I do that, I get a scale factor of 0.6. Okay, now what I'll do is I'll check the width. I guess that's the height, not the width, hey? You can tell I'm sick. Okay, so new divided by old. Well, as soon as I punch that in my calculator, what I'm going to see is that's 0.666666 repeating, right? Well, friends, I can stop right there. As soon as I see that these two scale factors are not the same, since the k value or the scale factor is not the same for all dimensions, we immediately are not similar. Okay, I don't feel the need to continue on to find the last measurement for the width. Who cares? As soon as I see that two scale factors are different, immediately they're not similar. All right, so again, always just looking at all the different measurements and see what comes up. Okay, let's do one more, friends. Pardon me. Canada Post sells pre-packaged boxes for mailing. All the boxes are similar. If the proportions on the boxes are labeled, find the height of the larger box. Okay, so since we know that these boxes are similar, what I know then is that this box here is an enlargement of this box here. So what I'm going to do is I'm going to find that scale factor. So 75 divided by 30. And when I do that, I get a scale factor of 2.5. Well, the measurement we're missing is this one right here, the height. So to find my height, what I'm going to say then is my new height is equal to my old height times my scale factor. So my new height is my old height of 20 times my scale factor of 2.5, which will give me 50 centimeters. So my new height, because these boxes are similar, I just multiply by the scale factor and I am set. Okay, friends, there's similar objects. I hope that sounded okay, even though I'm pretty sick at the moment. Good luck. See you another time.